Hello, good morning.
Good morning.
Benjamin.
Yeah. Can you hear me?
Yeah, thank you for
All right.
joining. Excited to have you here, present the project.
Yeah, I'm also excited.
Let's give it a couple of more minutes and see if more people join, and then we can get started.
Sure.
And I posted the link to the meeting notes. If you can please add yourself as an attendee.
Okay.
Hi. All right, I think we can go ahead and get started.
Okay. Can I share my screen?
For sure.
Okay. Can you see the slide?
Yes.
Okay. All right. So I'm Benjamin Ho. So the senior architect of CodeSphere. I'm also the member of OpenFunction and Fluent. So I'm happy to be invited by Ricardo to this community meeting to share with you what OpenFunction is and how we build it. So, oh, sorry. Okay. Can you still see the screen?
Yep. Okay. We can see it.
Sorry. OpenFunction is a open source native FaaS platform. So why we build such a platform in the first place? So I will explain that and how we build this platform. And following that will be the introduction to OpenFunction, including several components and the early adopters, contributors, the roadmap. In the end, there will be 2 demos. Yeah. So why we need open source native FaaS platform? In recent years, we have heard multi-cloud, hybrid cloud many times than ever. I think it is because Kubernetes bring the possibility of cloud agnostic. So, but as for the service or FaaS, it's difficult to be cloud agnostic because each cloud provider has its own FaaS platform, and usually these platforms are tightly coupled with their own backend services. So it's difficult to be cloud agnostic. So is it possible to build such a FaaS platform? So I think the answer is yes, because the new progress of cognitive serverless technology make this possible. I think the most famous technology is Knative. I think. But today I want to talk about another two technology, the CADA and Dapper. So CADA is an excellent project to scale the workload or the applications on the Kubernetes platforms. So it can we can use CADA to decouple the auto scaling of an application with many others different unit sources. So for example, you can use it to scale based on the open source unit sources or the cloud provider unit sources. So this is the CADA. We can another technology is Dapper. We can use Dapper to decouple the distributed application with the underlying backend services. For example, we can use the PubSub building block to decouple the PubSub activity with the underlying MQ, and we can use the binding building block to decouple the input-output. We can use the stateful state management building block to decouple the state. So usually FaaS platform supports several languages and also can communicate with many message queues. So let's suppose our FaaS platform can support 5 languages, and they want to communicate with 10 MQs. Without Dapper, each language has to use its different SDK to communicate with different message queue. So that ends up with about 50 implementations. But with Dapper, each language only need to use Dapper SDK to only need to communicate with Dapper using Dapper SDK, and Dapper handle the REST communication with the message queue. So we only need 5 implementations in this case. So the complexity of the FaaS platform has been greatly reduced. So this is why we use Dapper in a FaaS platform. It's like adding an additional layer between the FaaS and the backend services. So Dapper is like a unified interface for the bus layer, right? Actually, a couple of weeks ago, we have shared how we use Dapper in OpenFunction with Dapper community. And the 2 founders of Dapper, Mark and Yaron, they are glad to see the integration of Dapper with the Solid function runtimes. So, and finally, what is OpenFunction? Actually, there are 3 components under the function umbrella. The build block, the build component is used to build function source code into container images. Currently, we support using the build packs, Kubernetes build packs. We have done some customization on the Google Cloud Function build packs. The other 3 Dockerfile build technology, we can use them to build applications for now. So regarding the serving runtime, I think we support sync runtime and async runtime. The sync runtime currently Knative is the only supported sync runtime, and we are planning to support CADA HTTP in the future. And actually, one of our maintainers is contributing to CADA HTTP project now. I think the most differentiating feature of OpenFunction is the async runtime. It's powered by Dapper and CADA. Another component is events, OpenFunction events. It's kind of like the Knative eventing, but actually it was inspired by Argo events, right? I will explain later.
I have questions about the previous slide. So in terms of serving, The async runtime and sync runtime, or what is the difference between that? Sync runtime is just basically web requests, and then async runtime is event driven, or
Yeah,
else?
the sync runtime is triggered. The sync function is triggered by a HTTP request, and the async runtime is triggered by some event in the MQ or yeah.
Got it. Got it.
It's
Thanks.
basically like that. For the sync runtime, you have to the client has to get the result before the client return. But the async runtime, user just call the just put through the event into the MQ and don't care what happened after that.
Got it. Got it. Thanks.
And the OpenFunction build, whenever a function is created, builder will be launched. The builder will in turn create the shipwright build and build run. And together with the build strategy, the shipwright will create a tecton task run. And the tecton task run will generate several build steps, and these build steps will be executed in order to build the function source code into the container images. So this is the build. As I have said, currently we already support the knative and the sync runtime, and we support the KDA and Dapper at the async runtime. They both can use Dapper to communicate with backend services. I think the difference is for sync runtime, we only use the Dapper's output ability because the input is a HTTP request. And for the async runtime, we use the input and both the input and output ability of Dapper. So that would be a demo for both runtimes. And we will add the KDA HTTP as the another sync runtime in the future. And we are also considering to use pod pull method to improve the code start time for a function. So whenever function container is created, it will be created in pod in the pod pull. So the code start will be reduced. So this is the serving part. And OpenFunction events, it was inspired by Argo events, to be honest. And I think the difference is the event bus under the underlying broker or message queue is decoupled by a Dapper pops up building block. So user can use Kafka not streaming or GCP pops up or Azure event bus as the event bus. So it's not tightly coupled with any MQ. So whenever events can be seen in the event source, the event source can trigger a sync function directly or write the events to the event bus. And whenever events are written into the event bus, sync function could be triggered directly, or user can define a trigger. The trigger to filter the events he interested. Whenever filtered events comes out, it can trigger the sync function directly or return the filtered events back into the event bus. So this is how OpenFunction events works. Another important part is the functions framework. We have actually this was inspired by the Google Cloud Function framework. We have added some our own function signature here. Both the sync function and the async function can use the same function signature to write functions. And there are several components here: the context, a plugin, runtime, and finally the framework. The framework just combine all these components together. it read the function context, register the plugin, create the runtime, and start the runtime. Whenever the function is triggered, the runtime, the function framework will execute the pre-hooks and call the user function and execute the post hooks. There are some details here. If you are interested, you can see here for the proposal and the implementation. The reason we add the plugin mechanism here is to add the function tracing ability. So tracing the performance is important to function. So we have discussed with the Apache Skywalking community to add the tracing ability to OpenFunction. This is an example of function use case. User can trigger HTTP request to a sync function, and the sync function will then send some data to the Kafka server through the data sidecar. And whenever there is a message in the Kafka server, it will trigger async function to up and running. So to trace the performance of the sync function and async function in this user case, user only need to add something like this, add the tracing configurations to the functions annotation. You can see here that the provider is a Skywalking and the OAP server and some tags. Of course, user can put these tracing configurations into a config map. In this way, all the functions can use the same tracing configurations. So if you add, if user add this tracing configuration to both the sync function and the async function, he will see the call stack like this in the Skywalking UI, and the tracing data like this. Actually,
one question that I have about this is, are you using open tracing standards for this? I would imagine yes, right?
Not yet. We are planning to use support open telemetry, but open telemetry is not yet supported. It's a Skywalking standard still.
Okay,
but,
so it's in the roadmap. It's in the roadmap. Okay.
Yeah, but we have a plugin mechanism, so it can be supported very easily to use Skywalk to use OpenTelemetry. Yeah.
Awesome. Great. Thanks.
And here you can see the this is the Skywalking demo. You can see here there is function page. You can see that the OpenFunction is supported here. This is the OpenFunction example. You can see the tracing data here. Yeah. So this is the Skywalking tracing. Okay. This is the tracing part. So adopters and contributors. One of the major telecom company in China is using OpenFunction to build a FaaS platform. And another company is an autonomous driving company, UIC. They are using OpenFunction to process the vehicle data. And they are also active contributors and maintainers for the OpenFunction project. They are planning to, they are working on the Node.js and Python function runtime now. Chunxiang is a low-code platform. They are using OpenFunction as the for their plugin mechanism. And there are also some contributors to contribute to the .NET function framework. Here we are going to support Node.js, Python, Java, and .NET function framework. Just a few days ago, maintainer in the Dapper community said Dapper will be working together with the Kukas community and to make Dapper can run on the KUKA's environment. So they are interested in working on the OpenFunction to have a Java function running in the KUKA's environment. It will be much faster than the original Java program. So this is also on the roadmap. We are going to support OpenTelemetry for as another tracing provider. Finally, and the OpenFunction console, the UI is also in the plan. And we have taken a look at the service workflow project, and maybe sometime later we will support the service workflow. So this is the roadmap. I have two demos here. The first demo is elastic log alerting with async function. I have set up the using Fluentbit to collect logs and send it to Kafka. Launch the async function to read from the Kafka. Whenever the async function found error log, it will trigger an alert and send to the notification, send to the Slack. So we can take a look at the function code. Here is the function code. It's quite simple. It's just try to find the for error in the demo project namespace for pod word price, and whenever the condition is matched, whenever the function found an error, it will construct a alert manager alert and send to the notification manager. So let's take a look at the function YAML. Here you can say, here is how a function is defined. Here, this is the build stuff, how function is built. Read from this Git repo and output to this images. The runtime is the async. Here is the skill option. It's the KDA skill option. Control how the function scales. The KDA trigger. Watch for the logs on this topic of this Kafka server. Whenever the consumer lag is over 20, replica will be added. So this is a threshold. The async functions input is from the Kafka server directly. It's a Dapper component here. You can hear the Kafka server, the topic, consumer group, and the output will be the notification manager. It's defined also. It's also a Dapper component here. Just a URL. So this is how the function look. Let's take a look at
one question about definition. That's a Kubernetes CRD.
Yeah.
Okay, so you do have some sort of controller, right? Like when you install the OpenFunction. Okay, got it.
Yeah. Okay. Sorry. We can see the demo here. You can see here the function is building. We have done some customization on Google Cloud Function build packs. Actually, OpenFunction can build the Google Cloud Function directly.
Okay.
You can see here it's a building. Exporting the function images. Okay. You can see
Do you have documentation on the website to how to get started and how to install OpenFunction?
Yeah, but the documentation, the docs are more complete, are more the docs is good at the GitHub repo, but we are going to improve the docs on the official website now.
Got it. Yeah, because can you do have a lot of components, right? You have like, it sounds like you have build packs, so you have Kata, you have Dapper, so it's a bunch of things, right? So
yeah,
so that actually all of that stuff gets installed like on a Kubernetes cluster once you go through the installation process, or
yeah, we have a CLI tool to install the all this component. You can let's here the function is actually scaling, and we can see here to trigger an error output here. This is the WordPress site, so we trigger a not found error. You can see here we already have the not found here.
got it.
We can trigger another. Okay, it will take time. The function is it's scaling to 0, so it's a bit slower. We can see here the alert has been sent and triggered. So this is the first demo. We can delete this one. The second demo is this is the second demo. It's the tracing part. It's the previously tracing function. Use the send the HTTP request to a sync function. It will send some data to the Kafka and trigger async function. We can see here the how it's defined. This is the sync functions code. We just receive the signature, just receive the user input data and send to the target. This is how the function is defined. It also has the build part. It's using SwiftWrite and Takedown. So the serving part is the runtime is Knative, and you can specify the skill options here. The output part is a Kafka server. It's similar to the async function, just using the output. So this is the Knative definition. There is also the async function here, Kafka input. So you can see the function signature is the same with the sync function. Just a marshal retrieve the message received and print it out. So the input part, this is the function definition. It's similar. Build stuff and async function and Kata skill options here. Trigger. The trigger will be this Kafka topic. The input is from this Kafka topic, and the no output. The output is just ITD out, right? So we have already have deployed these two functions. And you can see here they all scale to 0 here. So this is the async function. This is the sync function. Let's trigger some payload here. I will send the this payload to the sync function. Let's see here. The sync function is starting. Okay. This code start is a bit slower. It's already started. The async function container is starting now. The message is received. So this is the demo. And we have the have a CLI tool to install the entire OpenFunction stuff. So user can use this CLI tool to install the different component. And now user only need to install the runtime he required. So he can only install the async runtime, or he can only install the sync runtime. So it's much flexible than before. Okay. This is my sharing thing, I think. Do we have any questions?
Yeah, I have a question. So what are you using it for currently? What are your use cases?
Use cases?
Yeah, for or currently in sort of production type of use cases. Oh, yeah.
Production type, yeah. The China Unicom is using OpenFunction to build the FaaS platform, and the autonomous driving company called USA is using OpenFunction to process the vehicle data. They are also the maintainers of OpenFunction. And this is the low-code platform, Quanxiang, is also using OpenFunction to implement the plugin mechanism, I think.
Awesome.
Okay.
Does anybody else have any questions, anything about the project, about the features? I think no questions. I think this is great. I'm looking forward to seeing more progress in the project. I assume you're thinking about also next levels. Did you apply for a sandbox in the CNCF?
Yes, we have applied the sandbox.
Okay, so I think the maybe next sandbox review might happen next week or so, and I'm thinking also that after you get into sandbox, you might want to also look at the next step, which is like incubation, right? But then it typically takes a little bit of time, maybe about 6 months to a year.
Okay.
Depending on how the project matures and how many end users adopt the project. But great to see. I mean, I think it's very useful. I think a lot of organizations might find it very useful to run like end-to-end.
Thanks.
Service.
Next, we are going to improve the documentations on the website, and we are going to release the 1.0 release in the next few months. Yeah. Okay, thank you.
Good. Sounds good. I think David is on a call, so I don't know. I think he will. I think it might be better to just chat about your projects on the next meeting.
That's fine. I just wanted to show up in case you guys want to do it, and also kind of see how the flow of the meeting went.
Okay.
Yeah.
Okay. Yeah. Yeah. I think in terms of the sandbox, I mean, there's no dependency on this meeting, so I think it just can be used as a reference for the TOC when they look at the project, right? But they can look at it later. So.
Yeah. Thank you.
All right. Thank you all. Have a
Okay.
great day. Okay, bye.
Thank you. Bye-bye.